Let's talk about epinephrine. Epinephrine is the ultimate fight or flight drug. This molecule is your body's adrenaline. Before we talk about mechanisms of action, when do we use epinephrine? So epinephrine is first-line therapy in emergencies. So something like anaphylaxis, cardiac arrest, shock refractory to fluids or pressors, severe asthma exacerbation, and it also can be used as an adjunct to local anesthesia to prolong the duration of that local anesthetic. Let's talk about the mechanism of action. So epinephrine, an endogenous catecholamine, stimulates multiple adrenergic receptors, mainly alpha-1, beta-1, and beta. Now let's understand those receptors. Let's talk about the heart cell first. So epinephrine goes into the heart and it stimulates the beta-1 receptor. Beta-1 receptor is a G-coupled protein. What that means is that it's connected to the GS protein. The GS protein stimulates adenyl cyclase. The adenyl cyclase converts ATP to CAMP, and that basically activates pathways that increase calcium in the myocyte. And ultimately, that results in increased heart rate, chronotropy, increased contractility or inotropy, and increased conduction velocity or dromotropy. Let's move on to beta-2 receptors. Beta-2 receptors are also G-coupled protein receptors. It is coupled with the GS protein, which activates adenyl cyclase, converting ATP to CAMP. And normally, calcium goes into the cell through L-type calcium channels, and it stimulates more calcium release from the sarcoplasmic reticulum, and then it binds to comodulin, which activates myosin light chain kinase. That phosphorylates the myosin light chains, which causes smooth muscle contraction. However, with increased CAMP from beta-2 stimulation, that inhibits myosin light chain kinase. The less MLCK activity, the less phosphorylation of MLC, the less contraction. So beta-2 receptor activation favors relaxation. Epinephrine also stimulates alpha-1. Alpha-1 is also a G-protein coupled receptor. It is coupled with GQ. When GQ is stimulated, it activates phospholipase C, which produces IP3, DAG, and ultimately it leads to an increase in calcium, activates MLTK, causing contraction. And you can find this in vascular smooth muscle. The ultimate effect will be vasoconstriction. Hopefully the diagrams made sense. Comment below if you have any further questions, and I'll see if I can answer.